It's time to export the knowledge. In this video, we're going to be doing another past exam question for methods. So this is the 2017 exam 1 for methods. No CAS, no notes. We're going to be looking at question 8 today. A total of 5 marks. Pretty poorly done question overall. This first part here, part A, really well done. It's the other two parts that are uh, more difficult. So let's um, let's just get started. So for the events A and B from a sample space, the probability of A given B is a fifth, and the probability of B given A is a quarter. Let the probability of A and B equal P. Find the probability of A in terms of P. So this is fairly straightforward. Try it. Okay, how can we solve this? Well, we know that we have to use this P, right? Because it wants in terms of P. So if it wants it in terms of P, we should probably use that. Now, this conditional probability is key, but which one to use? Because it wants the probability of A here. So do not use the wrong value. You can take a look at the formula sheet that's provided with this exam, and you can quickly realize that we actually want this second one here. So the probability of B given A is a quarter, and using the formula sheet, it's the probability of B and A all over the probability of A. Now, B and A is the same as A and B, so these probabilities are the same. So we have a quarter equals P on the probability of A. So now we just need to solve for the probability of A. We can cross multiply, or we can just take our times both sides by the probability of A. So we get a quarter of the probability of A equals P. So the probability of A equals 4P. So just taking a look at the exam report real quick. Right, 73% got full marks. They decided to manipulate the formula a little bit first and then derive an answer. I subbed in the values and then shifted things around from there. Generally well answered. Most common errors including solving for the probability of B and incorrectly transposing. So that's overall really well done. Okay, part B. So find the probability of not A and not B in terms of P. Okay, so this is worth 2 marks. Not so well done. If we take a look at the exam report, only 36% actually got this right. So give it a go. Okay, so there's two main ways of solving this particular part. We can use a probability table or a Venn diagram. So the exam report uses a probability table, so I'm going to use a probability table. We'll revisit this and do it the Venn diagram way as well. So I'm just going to quickly make my probability table, and we know that everything should add up to 1 because it's probability that we're talking about. Alright, so this key bit of information, A and B is P, so we put that in there. Then we look at the probability of A, we already calculated, it's 4P. And we can calculate the probability of B as well, using a similar method to what we did up here in part A, and we can show relatively easily that's 5P. And if you want to, you can rearrange this bit here. So it's going to be the probability of A and B divided by the probability of A such that B. And that's going to be our probability of B. And that's going to equal P on a fifth, which is 5P, which is what I said. Now this will be 3P. This would have to be 1 minus 5P to add up. And if we are going to do that, we need 1 minus 8p. And that's, we can stop there because we've found the value that we need. But we can continue if we want. That would be 4p, and this would be 1 minus 4p. And you can see that that adds up correctly, and we've filled in the table. So the probability of not A and not B equals 1 minus 8p. Alright, so let's do this with the Venn diagram quickly. So for the Venn diagram, here it is. We have A and we have B, and we know the intersection between them is P. Right, let's draw a border around it. We know A is 4p, so 3p has to be in here. And then we already solved for B beforehand, and we can quickly do that again. Right? We proved beforehand that the probability of B is 5p, so in here just B would be 4p, and then I would be thinking about this, because not A intersection not B is exactly the same as A union B not. So really we're talking about all of this outside area here. If we're talking about that, the whole thing should be 1, and then we just need to subtract the stuff that's inside. And what's inside? Well, it's 3p plus p plus 4p, right? And if we add that together, we get 8p, and that's our probability of A naught and B naught. Alright, so let's go take a look at the exam report. So here it is here. So 36% got full marks, and they have the probability table here. And then they solved, and they just followed the process and found the value. So students who scored highly usually use the table or Venn diagram to arrive at their answer. There were various misconceptions on the connection between the conditional probabilities. Many students assumed that the events were independent and multiplied. You can't assume it's independent unless it's specified in the question. Never assume that it's independent. Alright. Now, let's look at part C. So, part C, only 10% got full marks. So, let's go take a look. So, given that the probability of A union B is less than or equal to a fifth, state the largest possible interval for P. Interval is key here. Alright, so give this a try. Okay, so A union B. Now we can look at the Venn diagram or the probability table that we had beforehand, and we can see that A union B is going to be our 8p. So the probability of A union B equals 8p, right? So using that, 8p is less than or equal to a fifth. So if we divide by 8, p has to be less than or equal to 1/40th, right? The 8 times the 5 is 40, 1/40th. Now, this isn't complete. We need a lower bound, because can we have a negative probability? No, we cannot. Can we have the probability equal 0? Let's go take a look at our original thing, because this was the key difference between 1 and 2 marks. People didn't think about if the probability could be 0. Now, these conditional probabilities, are they 0? No, they are not. If these two conditional probabilities are not 0, the formula states that A given B has to equal the probability of A and B over the probability of B. The only way this would be 0 is if the probability of A and B is 0. But since this here actually equals some number that's not 0, P cannot be 0, and that is the contradiction that we need. So it's actually not equal to 0. It can't be. So let's go take a look at what the examiners had to say, right? So they followed the exact same process. They found this, and then notice not greater than or equal to, it's just a greater than sign, right? Most students identified the probability. Only a few students identified the correct interval. You got to mark each for your lower and upper bounds for P. Notation doesn't really matter. Because students did not consider that case P equals 0, common incorrect answers included, right? People just letting it equal 1/40th, or P is less than 1/40th, so negative probabilities, again, no, and including 0. You don't include 0 in this case. Why? Because of the conditional probability. The conditional probability is not 0, so P cannot be 0. Alright, so that's it for this video. If you have any questions, leave a comment down below or contact me on social media, and I will see you in the next video.